is lesson 10.1, day 2, association, identifying the patterns of association in that bivariate data, or those scatter plots that we were making yesterday. What is the association between all of those points? You can use scatter plots. Oh, this is in your packet. However, this first part of the lesson is not, so just follow along, and I will tell you when we're going to get to page 7 in your packet in a few minutes. I'm also on page 177 in volume B of your textbook. You can use scatter plots to identify and study the association between any bivariate data. A scatter plot can show whether there is an association or no association between the variables. If there is an association, it can be strong or weak, linear or nonlinear, and positive or negative. The association between variables in bivariate data. The variables can have a strong association, a weak, or no association. Strong association would look like this first graph that you see here. The data points cluster in a predictable pattern. Weak association, the data points cluster loosely in a pattern that is less predictable than the strong association. Or they're just all over the place, scattered everywhere. There appears to be no apparent trend at all, and a pattern cannot be found. So it depends on the clustering of data, the data points, when you plot these points on a coordinate plane. Strong association, very clustered in a similar pattern. Kind of in a, pattern here. We can tell the points are going up as the x values go up. The y values go up here in the weak association. No association, I don't know what's happening between those data points. When you have strong association, you can probably determine whether the pattern is positive or negative and linear or nonlinear. Bivariate data with a positive or negative association. So when two variables have a positive association, an increase in one variable corresponds to an increase in the other variable. So as the x variable is increasing, the y variables are also increasing. This is a strong positive correlation here. When you have a negative association, an increase in one variable, so as the x increases across from left to right across the x-axis, the y's are decreasing. So this is a strong negative association. So bivariate data with a linear or nonlinear association. When the two variables have a linear association, the points tend to cluster along a line. As you can see here, strong and positive linear association there. When they have a nonlinear association, the points tend to cluster along a nonlinear pattern. It can look more like a U, or it can be kind of a curve. So that's nonlinear, not in a line. If the two variables have a weak association, it's harder to tell whether there is really a linear or nonlinear, a positive or a negative other pattern between them. So sometimes bivariate data that have an association that can appear to have a weak association due to insufficient data points. When there is no association, if the two variables have no association, you can conclude that the bivariate data do not vary in a pattern with each other. So now we're going to go to page 7 in your packet. Page 7. Describe the association between the bivariate data shown in each scatter plot. Now remember, the association can be strong, weak, or no association. It can be, so that's the first thing we're going to look for. It can be positive or negative, second thing we're going to look for. And the third thing we're going to look for, is it linear or nonlinear? So those are the things we're going to answer on this page, linear or nonlinear. So, in graph E, describe the association between the bivariate data shown in each scatter plot. Number 6, graph E. Well, that looks like it has a fairly strong association, I would say, but it's nonlinear. They're not all over the place. They're in kind of a U pattern here. So I would say that that's strong nonlinear. Graph F, I would say that this looks like it's a strong positive linear. Strong association, they're clustered together. That's strong. Positive, they are rising across the graph. And they do appear to be going kind of in a line, so linear. So it has all three of those. Strong, positive, and linear. Let's look at number 7. I would say that that is no association, graph G. No association. And graph H, that looks like they're kind of clustered together, and it looks nonlinear to me. Looks like it does look like it's also heading in a positive direction too. I would say that's strong, but because it's kind of got this little sloping part here, it's kind of plateaued and then it goes up. I would say that that's a strong nonlinear, definitely, and maybe pushing it a little bit here saying that it's positive, but they do seem to be rising to me. I would say strong nonlinear positive for that one. On page 8, a scatter plot displays bivariate data on the time, x in minutes, taken by each student to complete a mathematics quiz and the number of questions, y, answered correctly. So time and number of questions answered incorrectly on a mathematics quiz. So identify any outliers. Well, an outlier, what is an outlier? An outlier is a piece of data that just doesn't appear to be in line or in that strong association with the others. This point right here, and it's in 15 minutes, they have one, they count up 2 boxes, that would be 1, then 2, then 3, then 4, then 5. So every 2 boxes up is 1. So that for 15 is the x value and 1 is the y value. Describe the outlier in this context. The data point 15.1 represents a student answered 15 questions, answered 1 question, not 15, that's 15 minutes, answered 1 question incorrectly, and she took 15 minutes to complete the quiz. Describe the meaning of the association between the 2 variables in this context. Validate the outliers are being different from the rest of the data points. So the rest of the data points, minus this one outlier, looks like it has a strong, they look pretty close, clustered, linear, negative. So I'm going to say strong, negative, and yes, they appear to be going in a line, and linear association. Indicates that the number of questions answered incorrectly decreases, yes, it's going down, decreases incorrectly, making mistakes, with increasing time taken to complete the quiz. The longer you take to take the quiz, the less mistakes you're going to make. That's what it says. Boy. The general trend shows that the number of questions answered incorrectly by a student who took 15 minutes to complete the quiz, so 15 minutes. So if I go over to 15 minutes and then up, it's somewhere, you know, like right around here, if I go between these 2 points here. It's around 11 questions that they would have gotten wrong. The general trend shows the number of questions answered incorrectly by a student who took 15 minutes to complete the quiz is around 11, that they made about 11 mistakes. However, the outlier of 15.1, oh, definitely. Most people made 11 mistakes if they finished quickly in 15 minutes. This person only made 1 mistake. Represents a student who answered 1 question incorrectly and took 15 minutes to complete the quiz. So definitely an outlier. Otherwise, if you follow this pattern, on average, it looks like they would, if you went quickly and you answered the quiz, you would make about 11 mistakes if you answered in 15 minutes. So outliers. Outliers are very different from the rest of the pattern that you see in the association between the two variables. Then on page 9, the scatter plot displays bivariate data on the length of each student's leg, x centimeters, and the distance of their single step, y centimeters. You would think, and it looks like the longer your leg as the x's increase, the longer your steps. That's what it looks like. The y's are increasing as the x's are increasing. Identify any outliers. Well, this point right here looks unusual. It's not in the pattern of these points, which seem to have that strong linear positive association. So describe the outlier in this context. So I would say that it's for 95 centimeters. That's the point 95, 32 and a half. Describe the outlier in this context. Well, that means that a student, this is the context, a student, so I'm putting the labels of the axes onto this point 95, 32 and a half. A student whose leg measures 95 centimeters had a single step distance of 32 and a half centimeters. I could have said that the other way around too. I could have said that the data point 95, 32 and a half represents a student whose distance of a single step is 32 and a half centimeters, had a leg length of 95 centimeters. I could have said it that way too, but I said the x value first. A student whose leg measures 95 centimeters had a single step distance of 32 and a half centimeters. That's the context. Describe the meaning of the association between the two variables in this context. Validate the outliers are being very different from the rest of the data points. Okay, so it's going to take a little bit to answer these. The meaning, well, it is the meaning of the association, and I already said it. It's a strong, positive, and linear association. And linear association. Indicates the distance of a single step increases with increasing leg length. Well, that makes sense. The longer your legs, the longer you can step. Increasing, leg length. The trend on this, the pattern, I'm going to say the trend or the pattern, the trend shows because we got to describe that outlier. Why is it not fitting with this? The trend shows that a leg length of 95 centimeters should be around, let's go back and look at this. 95 centimeters should be, I'm looking up here, that leg length should be around pretty close to 50. You know, if I'm following this red line that I drew in here, that looks like it's pretty darn close to 50 here, or this point right here is 50. Should be around 50 centimeters. Not 32 and a half like the outlier. So I'll put a comma there. Not 32 and a half centimeters like the outlier. They must have taken like a baby step or something. So the outlier is only showing 32 and a half. It really should be around 50. That's what that's explaining. And that's it for today. We're going to answer similar questions about strong, weak, no association, positive, negative, linear, nonlinear, and talking about outliers in your homework tomorrow in class.